شباب صبايا بعدنا بدرس complex numbers. So our lesson is about complex numbers. Please don't forget that the algebraic form of any complex number is represented by x plus iy. So the algebraic form of any complex number is represented by x plus iy, where x is the real part and y is the imaginary part. What about modulus of a complex number? Modulus means magnitude, length. So it's about the magnitude or modulus of a complex number. As I already stated that the algebraic form of any complex number is z equal x plus iy. The modulus of any complex number is represented by this form. So this means modulus of the complex number z. Since modulus is the same as magnitude, so we have to calculate it. And here is the root of the modulus of any complex number. It is radical x squared plus y squared, where x is the real part of the complex number and y is the imaginary part. So pay attention. It's the rule of the modulus of any complex number. Let's solve a direct example about the modulus. Given that z is equal to 1 plus 3i, it is a complex number written in algebraic form. So by comparison, we get that x is equal to 1, while y is equal to 3. And now we have to calculate the modulus of the complex number z. Simply, I'm going to apply the following formula. Radical x squared plus y squared. Replace x by 1 and y by 3. We get that the modulus of the complex number z is equal to radical 10. And what's our objective for today? My students, you should be able at the end of this video to identify the properties of the modulus. So you already know that modulus of z is equal to radical x squared plus y squared. In addition to that, you have to identify the properties of the modulus. So pay attention, we are going now to learn the properties of the modulus of any complex number. What about the properties? I will teach you the properties by direct examples on the concept. Let's take any two complex numbers, z1 and z2. We have to calculate modulus of their product. Before calculating the modulus, why not to calculate z1 times z2? z1 is given by 3 plus I, and z2 is given by 5 minus I. By expanding, multiplying first by first, then first by second, second by first, and second by second. Don't forget that I squared is always equal to negative 1. So replacing I squared by minus 1. And now add the real parts together and the imaginary parts together. After calculating the product of these two complex numbers, we need now to calculate the modulus of the product. As you see that the product of two complex numbers is always a complex number. How to determine its modulus? You simply apply the formula of the modulus, which is radical x squared plus y squared. X is the real part, while y is the imaginary part. So the modulus of the product of z1 and z2 is equal to radical 260. On the other side, you have to calculate modulus of z1 times modulus of z2. Here, times is between them. So as a first step, I have to calculate modulus of z1 by applying the formula radical x squared plus y squared, where x is a real part and y is the imaginary part. Next step, calculate modulus of z2. In order to calculate modulus of z2 again and again, we have to repeat the same process. We have to apply the following formula, which is radical x squared plus y squared. Modulus of z1 is equal to radical 10. Modulus of z2 is equal to radical 26. We have to multiply the two results together. So multiplying modulus of z1 times modulus of z2 means multiplying radical 10 by radical 26, which is radical 260. Please now take a look and compare the two answers. Modulus of z1 times z2 is equal to radical 260. Modulus of z1 multiplied by modulus of z2 is equal to radical 260. If we make comparison, we can say that modulus of z1 times z2 is equal to modulus of z1 times modulus of z2. So here is property number 1 concerning modulus of a complex number. We have to study it very well. What's about the second property of the modulus of any complex number? If we are asked to calculate modulus of z1 over z2, the first step is to find the ratio of these two complex numbers. How to find the ratio of these two complex numbers? Simply I'm going first to replace z1 by 1 plus 3i and z2 by 2 minus I. If we want to divide two complex numbers, then we have to multiply by the conjugates. Multiplying by the conjugate means switching the sign of the imaginary parts. So we have to multiply by 2 plus I. And now in order to calculate the ratio, we have to multiply the numerators with each other and the denominators by each other. Expanding the two brackets means multiplying first by first, first by second, second by first, and second by second. Don't forget that I squared is always equal to minus 1. After replacing I squared by minus 1, we will get that z1 over z2 is equal to minus 1 plus 7i over 5, which is the same as minus 1 over 5 plus 7 over 5i. And here is the algebraic form of z1 over z2. After calculating z1 over z2, we need to calculate its modulus. So the ratio of two complex numbers is always a complex number. How to calculate its modulus? Simply apply the formula of the modulus, which is radical x squared plus y squared, where x is the real part and y is the imaginary part. By calculation, we will get that modulus of z1 over z2 is equal to radical 2. Next step is to calculate modulus of z1 alone divided by modulus of z2 alone. So first step is calculation of modulus of z1. How to calculate it? Apply the formula radical x squared plus y squared. X is the real part and y is the imaginary part. we will get that modulus of Z1 is equal to radical 10. After calculating modulus of Z1, we need to calculate modulus of Z2. Z2 is given again and again by the same formula, radical x squared plus y squared. And now divide the answers by each other. Divide radical 10 by radical 5, you will get radical 2. Compare the two answers. Compare modulus Z1 over Z2 by modulus of Z1 divided by modulus of Z2. We will conclude that they are equal to each other. They are equal to each other, and here is a property number 2 concerning the modulus of any complex number. What's about modulus of Z1 plus Z2? Before calculating any modulus, let's find Z1 plus Z2. In adding two complex numbers with each other, we add the real parts. 1 plus 2 gives 3, and add the imaginary parts. 3i minus I gives 2i. After calculating Z1 plus Z2, we will calculate the modulus. Modulus radical x squared plus y squared. X is the real part. Y is the imaginary part. Find the modulus. It's equal to radical 13. On the other side, I have to calculate modulus of Z1 alone plus modulus of Z2 alone. Z1 here 1 plus 3i. In order to calculate modulus of Z1, apply the formula radical x squared plus y squared, which is equal to radical 10. Repeat the same steps in calculating modulus of Z2, which is equal to radical x squared plus y squared. X is the real part, y is the imaginary part. We will get that modulus of Z2 is equal to radical 5. Adding modulus of Z1 plus modulus of Z2, we will get the following answer. And now please take a look and try to compare the two answers. Are they equal to each other? The answer is simply no. So property number 3 states that the modulus of the sum of two complex numbers is not the same as the sum of modulus of two complex numbers. So modulus of Z1 plus Z2 is completely different from modulus of Z1 plus modulus of Z2. In some cases or in special cases, it can be equal, but we cannot generalize. So in general, they are different from each other. In special cases, they may be equal to each other, but in general, they are different. Again, Z1 and Z2, we have to calculate the modulus of that difference. Before calculating any modulus, we have to subtract Z1 from Z2. So I'm going to subtract 1 plus 3i from 2 minus I. The answer will be minus 1 plus 4i. Calculate the modulus of Z1 minus Z2. The answer will be radical 17. On the other side, calculate modulus of Z1 minus modulus of Z2. Z1 is given. Calculate its modulus by applying the formula radical x squared plus y squared. After calculating modulus of Z1, calculate modulus of Z2, which is given. Radical x squared plus y squared. Subtract the answers from each other. We can say modulus of Z1 minus Z2 is completely different from modulus Z1 minus modulus of Z2. So till now, we learned that modulus of z1 times z2 is equal to modulus z1 times modulus of z2. Same in division, but it doesn't include sum and difference. Z is equal to 1 plus 3i. Calculate modulus of z. Apply the following formula. X is a real part, y is an imaginary part. It is now required to calculate or to compute modulus of z bar. First of all, let's find z bar by switching the sign of the imaginary part. To find the modulus, apply the following formula and make your conclusion. You will notice that modulus of z is equal to modulus of z bar. Here is another property concerning the modulus of any complex number. Modulus of z is equal to modulus of z bar.